Hello friends, welcome back to STM Tutorials. Myself Ajinkya and we are here to learn the embedded system on STM32F103 controller. So let's begin. Today we will learn the basics of ADC. In this video we will see what is ADC, the need of ADC, its types, the ADC bus architecture, how to configure the ADC clock and important parameters of ADC. So let's start with what is ADC. ADC stands for analog to digital converter, which is a system which converts analog signal into digital ones, which means the analog voltage values converted into hexadecimal codes, which can be understood by the controller. So why ADC is needed in electronics applications? Most of the signals are analog in nature, like sound, temperature, pressure, light intensity, and etc. These signals are continuous in time domain. There may be certain actions depending on these analog values, such as to turn on AC on particular temperature, maintain the room temperature at 25 degrees Celsius, remove noise from the audio signal, and control the light intensity. So what are the types of ADCs? There are different types of ADCs such as successive approximation, delta sigma, dual slope ADC, pipeline ADC and flash ADC. You can find the detailed information on types of ADCs in the given website, or you can refer to the Modern Digital Electronics by R.P. Jain. Between the different types of ADCs, successive approximation and flash type ADC are widely used. There are certain important parameters of an ADC. The STM32 controller has 12-bit successive approximation ADC, which can operate in independent and dependent mode. The data alignment can be set to right or left. It has continuous scan conversion mode. The start of conversion signal can be given by a software trigger or an hardware trigger. The sampling time can be varied depending on the application. If you look inside the system architecture of an STM controller, you can find that ADC1, ADC2 and ADC3 are connected to Advanced Peripheral Bus 2, that is APB2. This is an important information which we will need while configuring an ADC peripheral. Here in the clock configuration window, you can see that APB2 peripheral clock is set to 8 MHz, which is generated by internal RC oscillator. So the ADC parameters can be set using the same clock, that is 8 MHz. As mentioned earlier, the STM32 has 12-bit successive approximation ADC. Its input voltage range is between 0 to 3.3 volt. The 12-bit resolution means it has 2 raised to power 12, that is 4096 steps. So, the voltage between 0 to 3.3 volt can be represented using one of the 4096 steps. The step resolution can be given by Vmax minus Vmin divided by total number of steps. So, to calculate one step resolution of 12-bit successive approximation ADC, which operates in the voltage range of 0 to 3.3 volts, the formula is given as 3.3 minus 0 divided by 4095, which is equals to 0.806 millivolt. This means that 0.8 millivolts corresponds to one step. So, the change of 0.8 millivolt will result in change of one step. The 0 volts can be represented by 0x0000 and 3.3 volt can be represented as 0x0FFF. I'll cover rest of the ADC related topic in my next video. If you enjoy the video, like, share and subscribe.